everyone, students. Welcome to your 4.5 notes. We're going to look at writing a function rule, see some applications. We'll start with some basics, and then we'll go into some business models that maybe someday in your life you will use as well. We've got some good stuff here. It's not just good tunes, it's good math, so let's do this. Writing a function rule. Write a function rule that represents each sentence. P is 9 more than half of K. So we just basically have to take this sentence and translate it into an equation. So P is, that tells me it's equal to 9 more, that suggests addition. Half of K would be written like this, 1/2 K. Now we could have done 1/2 K plus 9. That would be an equivalent statement. That would also be lovely. Alright, let's take a look at the next one here. 7 more than the quotient of a number n and 4. Okay, again, 7 more says 7 plus. The word quotient means division, and it's a number n and 4, so we know that's 7 plus n over 4, and there's that word is, which we know means equals, so it's equal to 9. Why don't you guys pause the video, do the third one on your own, and see how you're doing. Alright, welcome back. You can see what I've done on number 3. 5 less than 5 times a number x. Now you have to be careful with that one. It's not 5x less, it's 5 less. So you have to do 5x minus 5. It's really important that you have those in the right order. 5x minus 5, not the reversal of that. It is, again, is our equal sign, equals negative 27. Alright, let's do this with some real life models. So here we go. Write a function rule that, again, represents the situation. The price, P, isn't that nice that I gave you the variable right there? I'm a good guy. Of an ice cream cone is $3.95 plus 85 cents for each additional topping, T, on the ice cream. So the way we would set this up would be something like this. We would say that P, that represents, again, the price, P, write it legibly for you, is equal to, and I can just see it right there, $3.95 plus 85 cents for each additional topping. That's going to be 0.85 T. Alright, let's take a look at number 5. A babysitter's earnings, E, are a function of the number of hours. So we're saying E depends on the number of hours H worked at a rate of 7.25 per hour. So I would just write it like this, 7.25 times the number of hours. Pretty simple. There's nothing to add or subtract. We're not getting, $10 just for being cool, then 7.25 an hour. Some of you might, I don't know, not me. But anyway, so that is number 5. Let's continue on. We're cruising right through these notes. On number 6, it says John is 3 years younger than 3 times his brother Tom's age. Write a function rule that represents John's age, J, as a function of Tom's age, T. And then we'll deal with the second question, how old is John if Tom is 5, afterward. So we're going to write the function J, which is John's age, with respect to Tom's age, T. So J equals, now here it says he's 3 years younger than 3 times his brother Tom's age. 3 times Tom's age would be 3 times T, and if we want to go 3 years younger than that, we can just simply subtract 3. So there's the first part of that question. Okay, the second part says, how old is John if Tom is 5? So then we can plug in, instead of a T, we know T, Tom's age, would be 5. So we can just plug in that number. And so the age there is 12. And of course we know that would be 12 years old. Now there is an argument here that when you're only doing one follow-up question, the writing of the function isn't really that beneficial. I think there's a really good case to be made, though, especially if you're doing multiple follow-up questions. Then that becomes a really nice way to solve things where you don't have to reinvent the wheel, so to speak, each time. You can just simply plug in a number to an already predetermined equation. Let's look at number 7. This is the words you like to hear. Last one of the day. So it says a rectangle has a length that's 3 feet more than 2 times its width. What is the area of the rectangle when its width is 4 feet? Okay, so we're going to deal with the first part, which is just simply writing the function rule. Now we have to think a little bit on this. It says the length is 3 feet more than 2 times its width. So I'm going to put W right here. I'm going to put an S to make that its plural, like it's supposed to be. I think I just made it worse. There's a silent, invisible S right there. Not silent, just invisible. All right, so if this is the width and the length of the rectangle is 3 feet more than 2 times the width. Well, 2 times the width is 2W. 3 feet more than that would be plus 3. Now we have to do a little thinking here about, well, how do you find area of a rectangle? It's just simply length times width, or 2W plus 3 times W. I'm going to go ahead and distribute this W into both of these terms. So our function for area would be 2W squared plus 3W. So that's the way we can find the area of the rectangle. Whichever width W happened to be, we could find the area. Now, let's do the follow-up question. What is the area of the rectangle when its width is 4? So all I have to do to answer this question is anywhere in that function that I have a W, I'm replacing it with the number 4. Now we can go ahead and simplify this. So that's 2 times 16. I think we can handle 3 times 4 being 12. So this is 32 plus 12. So the area then is 44. Now I didn't label things over here, but I'm noticing labels on the original problem, and I should consider those. So the area is 44 square feet. Again, that's when the width is 4. Folks, that is the end of your 4.5 notes. I hope this makes sense to you. You will have the opportunity to get some practice and ask good questions in class next time we meet. You guys have a spectacular day.